Morning. Hey, everybody. All right, let's take a look at question one. All right. So we have a data set here with 5 numbers, right? And I want 3 things from it, right? I want the mean, I want the median, and I want the standard deviation, right? So okay, let's start with number 1, right? Let's say I wanted the mean. How do I find the mean again? Add them all up, right? So sum all the numbers. And then what do I do after I sum all the numbers? By the count of the numbers, right? So divided by the count of the numbers, right? So what that means is I want to do 12.34 is 45.67 plus I'm gonna skip a few all the way down to the 56.98. You guys get the idea, right? And I'm gonna divide that by how many numbers? Exactly. That's beautiful. All right, so what's the sum that you guys got? For the sum?
For the sum, oh, for the sum, I got 155,
150.
109. And then that's when you divide it by 5.
Okay, and then what you got?
180.
Everybody agree with that? Everybody got that? All right, good. All right, so now, how do I do the median?
Oh, we list all the numbers, we list all the numbers in order. And then total.
Very good. So I got to put them in order first, and then I'm gonna find the middle number. So what's the smallest number here?
80.
8. Very good. What's the next smallest number? 12. Okay. Okay. 45.
Yeah.
45.
32.1.
Oh, 32.1. Okay.
Yeah, and then 52. And then
Perfect.
units will be 32%.
And then we want to cross out the ends. Bop, 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 bop. Very good, right? So we got the 32.5, 31.08, right? All right, here we go. Standard deviation.
All right, before y'all all solve it, I'm just, all right, go ahead, continue. I'm wrong in that middle.
You wrong with the standard deviation?
No, I think I'm right, but exactly what, how I'm in the class.
Yeah. The other way? That's fine. As long as at the end of the conversation we all have the same number, we're in good standing, right? My favorite way to do it, is to use the computation formula. So all I got to do is find my x's and then find my x squares. So what's my x's here? I'm just copying from the median. You do not have to put them in order to do this method, right? I'm just copying from the median again. That's all, right? But if you guys want to copy from the original question, that's fine. All right. So I have 8, 12.34, 32.1, 45.67, 56.98. And then I want to add all the x's together. Forget 155.07. What happened?
First one, so, that 8.
Uh-huh. Oh, 64. Yeah. And what's the next number? Okay. 1030.49. 41 what? Oh, just one. Okay.
And then 2085.7489.
Wait, 20. Oh, like 2085? Hold on. Point what?
0.7489.
Very good.
And then 3246.7204.
Very good. And then what is the sum of x squared?
579.1849.
Do we all agree? Good, good, good. So then now we want to use that computation formula, right? So our variance, let me do it on the bottom real quick. So our variance, which is s squared, is going to be the sum of x squared minus, open parentheses, the sum of x squared divided by n, and all of that divided by n minus 1. You do not need to memorize this. I'm copying it from the formula sheet, right? This is in chapter 3 on your formula sheet. I'm just copying it straight from there. All right. After that, what are we going to do? Plug in the numbers. So I have the 6,579.1547 minus, open parentheses, the 155.09. Huh?
1549.
1549. Thank you. And then we're going to square that divided by 5. And then all of this divided by 5 minus 1. Type this in your calculator the same way that it looks here. Don't do the top and then want to divide it. None of that. Type it in straight and click enter. All right? And then yeah, what do we get for that?
1432.
So 432.1432.
33.
33.2.
There's no way to,
What you got?
so in the end, right, because the way I did it.
Huh?
442.
442. Gotcha.
Oh,
So this, you might not have that. This you should have.
see, but I did it this way. I had a,
Mhm. That's fine, but this number here should be the same as our number.
And that's how I got when I got the square root.
And then when you square it,
Mhm.
but this number should match this number. If it's right.
okay.
Mhm. So let's see. Let me verify. Since we got two different numbers, I'm gonna verify real quick.
Yeah, because I did it this way. I don't know. I put each number on the bottom.
Another thing too, right? When you're doing it that way, do not round. That's another thing. You hear me? Like that's another thing. When you're doing it that way, do not round. If you round, that'll cause error in your answer.
Also, that's,
Yeah. But let's see, because you might be right and everybody else might be wrong. Who knows? All right, I'm gonna verify it right now. All right. Well, let's see. So I got the same thing here for the sum of x squared. That's straight, and I got the same thing for the sum of x. So yeah, that looks like that checked out. Yeah. But wait. Maybe they typed this in wrong. Let me verify that. So for the variance, so I got the sum of x squared minus the sum of x squared divided by the n, which is 5. Then we want to divide that again by the 5 minus 1. All right, so I got this answer here. So this is right. All right. So if we're doing it your way, right? And it's fine if you want to do it straight or something like that. That's fine, right? No rounding.
Okay.
No rounding, right? So to do it the other way, if I was gonna do x minus the mean, first I need to find the mean. So 31.018 is our mean, right? We knew that from before. So if I'm doing x minus the mean, this will be this number minus this.
Oh, that's what I'm doing that, okay.
Yeah, it's fine what you're doing, but I can't have no rounding. That's the big thing. So when I do x minus the mean, right? My first number here is negative 23.018, negative 18.678, 1.082, 14.652, 25.962. This is x minus the mean for those doing that other way, right? Next, I want to square all of those terms. So x minus the mean squared. Let's take a look at what that is. Again, I don't want no rounding. All right. So squaring all of those terms, I have 529.8283. I have 348.8677, 1.170724, 214.6811, 674.0254. After you get that, you have to add all of those numbers together, right? So the sum of x, let me do that again. The sum of x minus the mean squared. Let's take a look at that. So the numerator of what you're dividing should be 1,764, so 1768.57328, right? That's what the numerator should be, right? And then when you divide that now by 4, right? That's how you get the variance, right? And just to verify that it's the same, right? I'm going to show you right here. I'm going to take this number here, divide that by the 5 minus 1, which is 4. And as you can see in the second way, these numbers match, right? Same thing, all right? So if you're doing it the second way, that's what you should get, right? Which one? The first one, right? Which one? This? The fraction button. Use the fraction button, type it in the same way it looks right here.
So you do fraction first?
Yeah. And then do the numerator, then do the fraction again, all that good stuff. All right. Nothing wrong with doing the standard deviation either way. It's just that you have to remember no rounding. I want all the numbers to be used. All right. Anyway, let's talk about the standard deviation, which is the answer to what we're actually looking for. Standard deviation, S, is equal to the square root of S squared, which in our case is going to be what? It's going to be the square root of the 442.14332, which is, let's take a look. So I got 21.0272. If you want to round off the standard deviation, you have my blessing. But you're not allowed to round off getting to the standard deviation. Okay. So that's question one. Any questions on this? Good. All right, let's look at question two. So this is a little bit more than what we're used to, right? Our story is there's a local ice cream shop owner, and he's curious about the relationship between the daily high temperatures and the number of ice cream cones sold, right? So she collects data for 10 days, right? So here's our 10 days, right? In one column, we have the temperature outside, and in the other column, we have the number of ice cream cones that are sold per day, right? What we want to do is we want to create a scatter diagram. Then we want to estimate the correlation coefficient, and then I want you to interpret your results. All right. So let's do this real quick. I think for this one, I'm gonna they always do this. All right, I'm gonna call ice cream my X, and I'm gonna call the high temperatures my Y. Right? Reason why I'm doing that, I'm looking at the data itself, right? And for the ice cream, I want to go from like 0 to 200, but for the high temperatures, I only want to go from like 0 to like 30 or 32. But you get the idea, right? From like 0 to like 32, right? So my Y's tend to be shorter than my X's, so that's why. I mean, like this rectangular, the projector and all that. Yeah, that's why. So it doesn't matter. Still get the same answer, right? As long as you're consistent and you use the story, that story matters. Use the story with you. Now, let's say that uh on the test, they flat out tell you X is this, Y is this, then you have to do that, right? But when you have it in a story format like this, right? Whatever you want to call X, whatever you want to call Y, right? Also on your test, you guys will be given a grid, like yeah, to do your graph, right? So you can make it real nice and pretty. So with the grid, you can actually estimate it out better than what I'm doing here, you know? So that's gonna help as well. All right. So I'm gonna pull this out to about here. That's my X, that's my Y, right? I'm gonna call X the ice cream. And I'm gonna call the Y the temperature. And let me see what units we have the temperature in. Celsius. Okay. So that's my temperature, that's my ice cream. So for ice cream, I want to get from 0 to 200. And I can do it however I would like to do it. What's my smallest number here? I think the smallest number there is 70. You can do it by 50, right? My smallest number is 70, right? So, and I want to get to 200. So I'm going to skip a few numbers. And I'm going to start off at 70. And I feel like I want to go up by, what's that, maybe tens? Or is tens too much? 20s maybe? 20s? All right, let's do 20s, right? So 70, 90, 110, 130, 150, 170, 190, 210. All right, that works. All right. And then for the temperature, I want to go from 0 to 32. All right. What's the smallest number there? Let me take a look. Smallest one is like 18, I think. All right. So since the smallest number is 18, I feel like skipping a few numbers, going to 10. I'm gonna start off with first number 10, and then we want to get to 32. How y'all want to do it? Fives? Fives is good? All right. So 15, 20, 25, 30, 35, and then that's it. All right. So what this little kind of sign looking thing is, right, is telling you that I'm skipping numbers from 0 to there, right? Just to make my graph a little more appealing, right? You guys won't have as complicated a scatter diagram on your final, but still, this is good practice, right? And then now you just have to make your mark, right? I just want to be clear. So I'm calling the ice cream is my X, and my temperature I'm calling Y, right? So a pair is going to be, for example, 120 comma 25. That's going to be a pair, right? So it's always like for this story, this column and then this column, right? So then now let's mark that up. So I have 120 and 25, right? I think 120 is somewhere like here. Go up to where 25 is, and boom. You don't have to be super precise, right? Just try your best, right? Just try your best. You guys, we're not computers, right? We're just trying to get the best that we can, right? Next, I have about 150 and 28. So let's look at where 150 is, go up to where 28 is. I think 28 is somewhere like here. Just making it up. What's the next one? 80 and 20. There's a rule called the 80-20 rule. I should look that up. All right. And then we got the 180 and 30. All right, let's go 180, 30, somewhere like right here. Then I got 122. Not so bad. 100-ish, 22-ish, somewhere like right there. I got 130, 26. Okay, so 130, 26-ish, then I don't know, somewhere like right there. Then I got a 70 and an 18. So 70 and 18-ish, somewhere like right there. Then I got a 200 and a 32. So 200, somewhere over here, 32, I feel like it's like somewhere right there. Next, I got 110, 24. Let me see, 110, 24-ish. Oh, somewhere like right there. And then I have 90, 21. Come across to 90, 21-ish, something like that. Okay. This is my scatter diagram. Is there any questions on how to do the scatter diagram? All right. What would you estimate the correlation coefficient to be here? No. Like estimate. Like, all I want to know is it positive or negative? Positive. Yeah. That's all I want to know.
Well, the temperature increases.
So we're gonna get that's my next question.
As the temperature increases, the number.
So hold on one second. Estimate the correlation coefficient to be positive, right?
Also, you don't need the, percent.
Nope.
You need to know if it's positive.
Nope, I'm not asking for the number.
Okay.
But I'm happy that you can find it though. I appreciate that.
Well,
However,
didn't that answer, though? I know.
yeah, it would have. Yeah,
It wouldn't, there
Yeah,
wouldn't be point.
yeah. But we're not asking you for that. We're just asking you to estimate what you think it is,
Okay.
positive or negative,
Positive.
right? So now the interpretation, right? We said positive. So as,
The temperature?
not temperature, as ice cream
Oh, I.
which is our X, increases temperature which is our Y, increases. Right? So as our X is increasing, our Y is increasing. Had this been negative, as our X is increasing, Y is decreasing. That's it.
Oh, one can that shows more, right?
Right, where majority of it is going. Yeah. Because it could be more scattered than this, but it would still be a trend there, right? And I want to know where you think that trend is going. That's it. All right, that's question 2. 3. This is the easiest question on your exam. Don't nobody get this question wrong. All right? The easiest question. Y'all don't even got to show work for it. Just write down the answer. That's how easy it is. All right? You on number 5, Ron? All right, let's check it out. Let's check it out. We'll do this in one in orange, right? So a survey was conducted among college students to explore the relationship between their chosen major and their career aspirations, right? So science major, boom, humanities major, business major. Some people want to do research academia, business finance, or creative arts. And then there was an other category as well. All right. So anyway, let's take a look at this. What is the probability that a randomly selected student is a science major? What's the answer? 50. No. What's the answer? 70 over what? Perfect. Does that make sense? Right? Because look, science majors, I want all of the science majors, 70 over the total of everything, 210. All right. B, what is the probability that a randomly selected student has a career goal in business and finance? Over what? That's what I'm talking about. So business and finance is this 70. Okay? Over the 210. That's how you get that one. All right. Simple, simple, simple. Easiest question on the whole test. Go ahead. Nope. That's all I want. 70 over 210. All right. But I know you guys all have calculators and y'all can type it in, so we don't need all that. What is the probability that a randomly selected student is a humanities major and has a career goal in creative arts? Humanities major and creative arts. Good. 30 over 210. Everybody got that? Yeah. That's all I'm looking for. Everybody got that one? 30 over 210? No problem. Number 4. What is the probability that a randomly selected student has a career goal in research and academia given that they are a business major? 50 over 80.
50 over 80.
Right, 50 over 80. This is good, right? So just to recap how we did that, out of all the business majors, 80 of them, how many of them want to do business and finance? 50. So 50 over 80. That's how we do that. All right? That's our given statement. 5. What is the probability that a randomly selected student is a science major or has a career goal in business and finance? No. Maybe. I don't know. Let's see.
I'm giving you
The answer, got you. Let's check it because I'm actually not sure. All right. So for number 5, right? We want to know what's the probability of science or business, right? The probability of science or business, this is going to be equal to the probability of science plus the probability of business minus the probability of both of them, right? So what's the probability of being a science major? 70 over 210, right? Plus, what's the probability of having a career goal in business and finance? 70 over 210. Now, how many people have a major in science and a career goal in business and finance at the same time? 15 over 210. Very good. Okay. 125 over 210. Okay. Yes. Questions on that? Questions on this one? So we good with the or? Good with the or? All right. Do the data suggest an association between a college major and a career goal? Yes, it does. That's not going to be on your test. All right. That's it. We good with this? Easiest question on the whole exam. All right, let's look at question 4. All right. Oh, this is gonna be real simple right here. A local bakery produces 2 types of pastries, right? All right, I just saw Den of Thieves, right? Poisson. Yeah. And muffins, right? The bakery sells 60% of the poisson they bake each day. Overall, 40% of all pastries, both croissant and muffins produced, are sold by noon. Of the croissants that are sold, 75% are sold before noon. What is the probability that a randomly selected pastry produced by the bakery is a croissant and is sold before noon? Good. That's it. Right? All right. 0.45. Let me write that down. 0.45. All right. So just to put the words to it, right? They want to know what is the probability of croissant and noon. I'm just gonna say 12 p.m. Right? Go ahead, that's fine. So then now what we have, right? Or what we're given in this question, we're given the probability of croissant, which is 60%. We're given the probability of 12 p.m. given all, which is 40%. And we're given the probability of what's that thing called now? 12 p. Yeah. 12 p.m. given croissant, which is the 75%. All right. So for our question, we want the probability of the 12 p.m. given the croissant times the probability of the croissant, which becomes what? That's going to be the 75% times the 60%, which becomes what? 45%. I will take 45% or I will take 0.45. Doesn't matter. Go ahead. Where did I lose you? With the croissant? Yeah. So it's all in the story, right? The bakery is making the croissant, right? And then, this one, 40% is everything that the bakery makes, right? That's the part that comes after the given, sold before noon, right? But the 75% is exclusive, right? That one is the croissant, right? And then, excuse me, is sold but before noon, given that it's a croissant and not a muffin. Something like that.
Before.
Exactly. Mhm.
I did that, given all that.
Yeah.
This is the fee of.
Okay, so this is the issue though, right? These right here are the B given A and A given B, that's what that is. Yeah, they're not like flat fee like this. Yeah. To be honest with you, right, keep it 100 with you, on your test, that top formula, the probability of A, and B, which is probably the A times probability of B, you'll never use that. Never use that on the test. Right? On the test, you won't get this story nonsense happening, right? You'll be given. If you're blessed, I'm not saying that every exam is like this, but if you're blessed, you'll get this question and it'll only have two numbers in it. I'm not saying that happens all the time, right? Like this is more common than not. And that's why I keep like prepping this with y'all. Mhm.
Chapter 5.
Chapter 5, right? Mhm. It will be, but what I'm saying is like this type of question with the ands, right? And they have like multiple given statements. This is what's going to be on your test, more likely than not. It's possible you could get the question that has only two numbers, and all you gotta do is multiply them. Then you're super blessed. But it's not given that it's gonna happen that way. You know? And then of course, question B, that's the easiest of all. Exactly, right? As soon as you hear or, you already know what to do, right? So they want to know what's the probability of books or computers. So books or computers, right? That's going to be the probability of books plus the probability of computers minus the probability of both of them. I'm just being lazy and I don't want to write out the word books, but I figure you guys get the idea. Book starts with B. So 65% are the books, plus 42% use the computer, minus 28% use both. 0.47. I like that. Or if you want to tell me, all right. Or if you want to tell me 79%, I'll take that. Anyone? Now, I know I just went through this. I didn't even read the story. Let's read the story real quick. A survey was conducted at a local library. Hold on. I'll make this real nice to make up for my failure. A survey was conducted at a local library. It was found that 65% of visitors borrow fiction books. It was found that 42% of visitors use the library's computers, and then 28% of visitors use both. Right? What is the probability that a randomly selected visitor to the library will either borrow a fiction book or use the library's computer? Right? Keyword there being or. Right? And that's where we get our or from right here. All right. I hope that makes sense. And together, A and B is 20. Yeah. Any questions on this? We're good? All right, let's keep it moving then. All right. So last night, right, I was watching on YouTube, right? There's a popular sports commentator. I like to watch his videos. He has like a YouTube channel with like little videos where he gives us like 2 cents about opinions and stuff like that. So I was watching his video last night and he gave me this statistic, right? So in a recently viewed YouTube video, it was found that 47% of Jamaican men's fraternity test results in the child not being their own. If 20 men are randomly selected, what is the probability that no more than 5 of the men are not the father of their children? How do I do that? How do I do this now? I want the probability of no more than 5. So what numbers are no more than 5? Right. So this is going to be the probability of x less than or equal to 5. So that becomes probability of 5 plus probability of 4 plus skip a few all the way down to the probability of 0. Okay, so we're on the same page, right? We have 2 ways that we can do this. You can either do it in the calculator, right? This will be binomial CDF, or use the formula sheet, right? Your n right here. Let's recap real quick. So my n is 20. My probability of success is 47, right? And then my r is no more than 5, right? Let me just write that out real quick. So n 20, probability of success is 47%. Or if you want to write it as 0.47, no problem. And then my r, which is sometimes written as x, is going to be 5, 4, skip a few, all the way down to 0. All right? All right, so calculator. What's the answer there? Let me see who remembers how to use a calculator for this question. Remember, we're gonna do binomial CDF. You got the final answer? Hold on one second. Hold on. Let me just write this out real quick. So we got the trials, which remembers the same thing as your n. This is going to be 20. You have your probability of success, which we know is going to be the same thing as our p, which is a 0.47. And then we have our x, which is the same thing as r, which in this case is going to be 5, right? Because remember, binomial CDF is for less than or equal to. So, okay, what answer do we have? Perfect. Now, those of you using the formula sheet, do we agree? Did you guys get that? There's no 0.47? Got you. The one on your test will actually be on the formula sheet, by the way. So let me verify this real quick. Right, I got the same answer. So good job, guys. All right. But on the actual test, my fault. Because again, like I said, I wrote this question. Like this is taken from real life. This is not a true question, so to speak. Yeah. But what's it called? On your test though, you will have one that you can actually look up in the formula sheet and add up all the numbers to get it. All right.
What is more?
when it's more than, so you're gonna have to take the answer that you get like this, and then just do one minus it to do greater than. That's how you do greater than.
So I'll go through the binomial, see if you ever.
Yes, but you're gonna like, you're gonna do one minus the answer for greater than. Yeah. Mhm. All right. Next question. What is the expected amount of men who are not fathers of their children in Jamaica? Right? So expected value. Good. Is mu equals n times p, which in this case, n is what? Times. Good.
And that would be
9.4. I'll take it. Questions on that? Good. All right. What is my standard deviation?
sigma,
Mm-hmm.
square root n times p times q,
Good.
but in that case, it's 1 minus p.
Very good. So this is going to be square root 20 times 0.47 times open parentheses 1 minus 0.47.
That would be 2.9.
Wait, 83105. Okay. I like it. Everybody agrees? Any questions on this? This is our binomial distribution question. Good to go? Mhm. Yeah.
All it is, question 1 to 5, I get.
Uh-huh.
Like, and a little bit of 6, but like the only part I'm having talking with is that figuring out which one is a lower bound and upper bound.
I got you. Whatever's to your left, lower bound, whatever's to your right, upper bound. That's it. Yeah. Left lower bound. So whatever's to your left is the lower bound, whatever's to your right is the upper bound. Yeah.
Okay.
Yeah.
Beyonce to the left.
Yeah, exactly. Yes. So let's look at question 6 now, all right? That's where this question is coming from that he's asking. So the average height of oak trees in a large forest is 80 feet. Wow. So that means that my mu is 80 with a standard deviation of 15 feet. So that means that my sigma is 15, right? And then we're going to assume that the heights are normally distributed. So our first question is asking us, right? Because there's a part A and a part B to this question, right? What is the probability that a randomly selected oak tree in the forest is taller than 95 feet, right? So they want to know what is the probability of the tree being taller than 95. So taller means that this is going to be the probability of X, what, greater than or less than? Greater than 95. That's excellent, by the way. All right. So now, if we're going to do it in the calculator, right? First thing we got to do is draw our distribution, right? So here goes our distribution right here. When I say draw, I mean graph, right? The mean is what, 80? And then we have 95, which is going to be to the right because it's bigger than 80. And I want to know about the area to the right of it. So this area right here, right? Now, just for fun, let's pretend that I'm standing right here in the middle of the distribution. I'm always in the middle of the distribution, always, right? Whatever is to my left is my lower bound. Whatever is to my right is my upper bound, right? I guess this would be your left, right? This would be my, yeah, something like that. Right? So, that being said, right? This is we assumed that the tree's height is normally distributed. So this is going to be a normal CDF in the calculator, right? So normal CDF, right? So in the normal CDF, right, I need the mean, which in our case is going to be the mu, which is 80. I need the standard deviation, which in our case is sigma, which I don't remember what it is. It's 15. Thank you. Appreciate that. And then our lower bound, 95. Excellent. So then if that's my lower bound, what's my upper bound? Perfect. So there's no upper bound, so you should have 1E99. Then you click enter. What's the answer? What, 0.15865526. That's perfect. That's perfect, right? That's full credit right there. All right. Now, I'm gonna do this one more time though for those who don't have the calculator, right? So remember our question, right? The question was asking us for the probability. I'm just gonna put like a partition here just to show that this is the difference between it, right? They're asking us for the probability of X greater than 95. We have to change that X into a Z value, right? Because we can't look up an X distribution. We can only look up a normal distribution in the table. So this is going to become the probability of Z greater than X minus mu over sigma. Just plug it in. You have all the components already, all right? This is going to become the probability, excuse me, of Z greater than 95 minus 80, excuse me, over 15. This becomes the probability of Z greater than, is it 1? Is that 1 on the calculator? 95 minus 80 divided by 15, what's that? That's 1, right? So this is going to be 1.00. Remember though, in the formula sheet, right, we don't have probabilities for greater than, for greater than. We only have probabilities for less than. So what you have to do here is you have to do the complement of it, right? So the complement of this is going to be 1 minus the probability of Z less than 1.00. This you can look up in the calculator. I mean, on the formula sheet, excuse me. So this is going to become 1 minus 0. Look that up for me. What's 1.00 in the formula sheet? Ronnie, not for you. You have the calculator. Yeah. What's 1.00 in the formula sheet? Positive 1, by the way. Positive. These are for those that don't have the 36X Pro calculator. What we got? It's 1.0. Wrong table, wrong distribution. Right. 1.0. That's good. Good. Go across to 0. Wonderful. Good job. All right. Okay.
right? Not the other two, it's, table three, the one with the information table. I don't remember the number. But you have a calculator.
Oh, do the calculator, right?
Some people don't have the calculator, so I'm showing both ways.
Oh, okay.
You see? Is that number three? And for the O, or six zero. 8430.
So we got 0.8413. All right, and when we do that in the calculator, what's 1 minus 0.8413? Perfect. Same answer. All right. So you could do it either way. I feel like the calculator way is a lot easier, right? And the calculator way works for both questions even better. You know? So all right, let's do question 2. Question 2 says, right, from the same story, right? A group of 25 oak trees is randomly selected from the forest, right? What is the probability that the average height of the trees in this sample is greater than 95 feet? All right. Hold on 1 second. Awful messages right there. Where's my sample again? 25. So in this question now, right, I have an N, which is 25, right? Because, right? Wait, let me do it in blue. Hold on. I just want to show that it's connected. And this is part B, by the way. So I have an N, which is 25, right? Because I have a sample size, right? This is going to be an X bar distribution. So I have to find the mu for the X bar distribution, which is the same as the mu, which is equal to, what was ours? 80. But listen, this is what changes. All right. Very important when you're using the calculator. You have to find the standard deviation for the X bar distribution. The standard deviation for the X bar distribution is equal to the standard deviation divided by the square root of n, which in our case is what? This is going to be the 15 divided by the square root of 25. And I feel like that's 3 when you do it in the calculator, but y'all should verify me. All right. That being said, right, they want to know what is the probability of X bar greater than, let me just scroll up because I forgot, 95. They want to know what's the probability of X bar greater than 95. Draw your distribution out the same way we just did it before, right? So I'm going to have a bell curve. My mean in the middle is 80. 95 is again to my right-hand side because 95 is bigger than 80. And I want the area to the right, just like that. I want the area to the right, right? Let's pretend that I'm standing in the middle of my distribution. I'm always standing in the middle of my distribution. Always, right? Whatever is to my left is my lower bound. Whatever is to my right is my upper bound, right? Let's plug that in. So again, I want to do normal CDF, right? I have my trials, which is my N, which is going to be what? 25. I have my probability of success, which is same as my P, right? And that is what again? Wait, what am I talking about? Hold on. Wrong concept. Sorry, wrong concept. I'm sorry. We have the mean, which is equal to mu, which is 80. Sorry about that. We have the standard deviation, which is now 3, right? This is going to be equal to our sigma x bar, which we found out to be 3, right? Lower bound is 95. Very good. Upper bound is what? So 1E99. And then when we hit enter, what's the answer? So how many zeros before the 2? 6. So that's 4, 5, 6. And then there's a 2. And then what else? 8, 7. Perfect. All right. Long story short, the answer is 0. All right. And then that's the calculator way, right? For those of you without the calculator, let's say that we're going to answer the same question, right? They want to know what's the probability of X bar greater than 95. So what am I going to do? I can't look up an X bar distribution. I have to change it into a Z, but I have to use the other Z formula. So this is going to become the probability of Z greater than X bar minus mu over sigma over the square root of N. Just plug in the numbers. Very simple. You have everything. This becomes the probability of Z greater than 95 minus 80 over the standard deviation, which is 15, over the square root of 25. Just plug it in, right? This is going to become what? This is going to be the probability of Z greater than, what's that? 15 over 3, I believe. Something like that. Which is going to become the probability of Z greater than 5.00. Right? Now remember, my formula sheet, right? I cannot look up probabilities that are greater than. I can only look up probabilities that are less than, right? So that means that I have to do the complement of this. So this is going to become 1 minus the probability of Z less than, sorry about that, less than 5.00. So this is going to become 1 minus 0 point. Now we're going to look up 5.00 in the formula sheet, right? Find that for me real quick. Same thing, normal distribution, right? We're going to look for 5.00. So go down, find 5. So in our formula sheet, when our Z value is bigger than 3.4, right? we use 1 to approximate it, right? So this is actually going to be 1.00. And then 1 minus 1 is 0. Same answer. All right. Questions on the normal distribution? Anybody? So we good on this? Go ahead. Okay, so whenever your z value, like in this case, our z value is 5.00, right? Whenever your z value is bigger than 3.49, right? We use 1 to approximate the area to the left of it. Yeah, so the probability of z less than 5.00 is 1, right? And then 1 minus 1 gives us 0, which is the same thing as this, right? This, I know this is not true 0, but you see how many zeros I have before I even hit the number 2? That's like a really, really small number, like call that 0, that kind of number, you know? Yeah. All right. Let's look at question 7, right? So a researcher wants to estimate the average time students at a university spend studying per week. They randomly survey 100 students and find that the sample mean study time is 15 hours with a sample standard deviation of 4 hours, right? Construct a 95% confidence interval for the true population mean study time of all students at the university, right? So let's recap real quick. So randomly surveyed 100 students. So my N, in blue, is 100. We have a sample mean of 15 hours. So my X bar is 15. That doesn't look nice. Hold on, let me try that again. My X bar is 15, right? And then we have a sample standard deviation of 4 hours, right? So I have a S is equal to 4. We want to construct a 95% confidence interval. So my confidence level, I always, is 95%, right? I always like to write confidence level as CL just because that's my initials, right? But I know in the textbook they write it as C, right? So that's 95%. All right, what were you gonna say? Right?
Like my teacher taught me before.
Mm-hmm.
The S, it could be sigma, right? If they give you the population.
Not on your test.
Not on the.
No, not on your test.
So we're not gonna get this, population.
No. To be honest with you, if I'm gonna share my 2 cents with you, I don't even know why they even teach where that topic where you know what sigma is, right? Like realistically speaking, right? You're gonna tell me you know what sigma is, the population standard deviation, but you don't know what mu is? How is that possible? Like, you know how much work we have to put in? Like, you remember question 1? You know how much work we got to put in to get that damn standard deviation, and you don't know what the population mean is? That don't make sense to me. You know? This is more realistic, this question. All right, so we want a confidence interval, right? You remember that all confidence intervals are written as X bar minus E less than mu less than X bar plus E. By the way, I'm not making any of this up. This is chapter 8 in your formula sheet, right? I'm copying straight from chapter 8, right? Our margin of error, E, is equal to what? That's going to be our T critical times our sample standard deviation divided by the square root of N with a degrees of freedom of n minus 1. Right? Okay, I know what my sample standard deviation is. Cool. I know what my n is. No problem there. What's my degrees of freedom? Let's figure out the degrees of freedom. So my degrees of freedom, I'm gonna put it over here. My degrees of freedom, which is known as n minus 1, is gonna be what? 100 minus 1, which is what? 99. That's excellent. That's excellent. Now we want to look this up in our formula sheet, right? We want to look this up in the formula sheet. This is going to be the last table, right, in the formula sheet, the student T distribution table. That's what we're looking for, right? My degrees of freedom is 99, and my confidence level is 0.95. What is my T critical? Somebody tell me. And if you don't know how to find it, tell me that too. All right, now's the time to ask questions and everything. What is T critical?
1.92, 1.984.
1.984. Does everybody agree? Not good, because I'm not gonna lie, I don't know. But for T critical?
Oh, no, okay, yeah, I have 1.984, yeah.
1.984. Everybody got that?
You're right, yeah. Because you know what I was thinking of? I was thinking of talking,
The final answer? Oh, the CIA.
Yeah, the CI, that's
Yeah.
what.
We'll get into that.
Because I know after the TC, I can get the, ME, right?
The margin of error.
The margin
Yeah,
of error.
ME,
Yeah. Alright, yeah, alright, yeah, come on.
Everybody you got that? All right. So let's look at how we get this, right? Again, we're using the last table on the formula sheet. That's for the student T distribution, right? Last table. Just bear with me 1 second. We'll have to go down a little bit more. All right, so I'm on the last table. I'm gonna say 95. Okay. All right, real quick, I'm just gonna grab the table. We're gonna take a look at it, right? This is our table right here, right? My degrees of freedom go straight down. My confidence level goes straight across, right? The confidence level that I have in this question is 0.95, right? Let me just highlight that. 0.95 right there. And then my degrees of freedom we found is what number again? 99, right? So do we have 99 here? And what do I do if I don't have 99? The closest number, so what is it? No. No, we do the closest number that is smaller. So 80, right? 80. Right? So what is it? Exactly. That's the one. You learned a different way? What did you learn? The closest number that is smaller. Not higher or lower, that is smaller. All right?
I give about one teacher get away and
Yeah.
then another person teach you because.
I got you. I got you. So let me teach you the correct way, right? Not everybody knows the correct way. When I'm doing this confidence interval, what am I doing, right? I'm trying to estimate what the population parameter mu could be, right? If I choose the 100 one, right? What I'm doing is I'm giving a range that is smaller. So there's a chance that that smaller range won't contain the population mean mu. If I use the one that's smaller, the 80, I'm giving a larger range. So there's a greater chance, a greater probability that I'm gonna capture the population mean here. Right? And that's what I want to do here. I want to estimate what that population parameter could be. Right? That's why we use a smaller one. Yeah. Your guy might not know that. So, oh. So we got what? 1.990. Let's go back over here. See how that other one was smaller? The 1.984, right? 1.900 is bigger, so that's gonna make the numerator of this formula right here larger. So I'm gonna get a larger range. That's what I want. All right. After this, after you figure out what the TC is, just plug it all in. This is simple math right here. Simple math. Right. So we have our margin of error is going to be equal to the 1.990 times the sample standard deviation, excuse me, which is 4 over, put a little x right here, over the square root of the n, which is 100. Right? A little calculator, bop, bop, bop. Tell me what E is. For her 0.796. That's it? Or is there more to it? That's it. All right. Can somebody else confirm that? You got the same thing? All right. After you figure out what the margin of error E is, right? Remember, my answer is a interval, right? So my final answer is using this top formula we have up here, x bar minus E less than mu, right? So let's do that. So this is going to be x bar minus E less than mu less than x bar plus E. And what's my x bar? My x bar in this case was 15 minus the 0.796 less than mu less than 15 plus the 0.796. Little math in the calculator, bop, 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 and we're done. All right, so what's 15 minus 0.796? 14.204 less than mu less than 15.796. This right here is my answer. All right. There we go. That's my final answer. That's all I'm looking for in a confidence interval. Is there any questions on this? Any questions? All right. I'm gonna need a couple more minutes from you guys to finish the lesson for today, but I just need to ask a quick question. I'll be right back. All right. Finish copying, make your notes. Be right back.
You have a permission?
Huh?
With any permission? No.
It's actually my online day for tutoring. So I just had to let them know, like, take a couple more minutes with you guys. All right. So confidence interval. Questions, are we good? Good? All right. Let's take a look at what we're looking at today. I'll make this real quick and nice. So what we're going to be looking at today, we're going to be looking at an introduction to statistical testing or statistical test. All right. So just to bring this back. So in chapter 1, we emphasize the fact that one of a statistician's most important jobs is to draw inferences about populations based on samples taken from the populations. Most statistical inference centers around the parameters of a population, often the mean or probability of success in a binomial trial. Methods for drawing inferences about parameters are of two types. Either we make decisions concerning the value of the parameters, or we make actually estimate the value of the parameter. So when we estimate the value or location of a parameter, we are using methods of estimation such as those we did in the last question, right? Where we're trying to estimate what could the population mean be, mu, from a sample that was taken, right? Decisions, it's a key word there, decisions concerning the value of a parameter are often obtained by hypothesis testing. This is the last question on your test, hypothesis testing, right? And then this topic will be studied further. Students often ask which method should be used on a particular problem. That is, should the parameter be estimated, or should we test a hypothesis involving a parameter? The answer lies in the practical nature of the problem and the questions posed about it, right? And then some people prefer to test theories concerning the parameters, all right? So let's get to it. So want to make this as quick and painless as possible. All right, so to do a hypothesis test, right? It's done in 5 steps, right? It's done in 5 steps, right? Step 1 is to state your hypothesis, right? State your null and your alternative hypothesis, right? So let me just give you guys the definitions of what the null and the alternative hypothesis is, right? So let's remember that this is, again, I always forget to bring my pen. This is step 1, right? Step 1. So step 1 is you're going to state your null and your alternative hypothesis. This is what they are, all right? So the null hypothesis, HO, is the statement that is under investigation or being tested. Usually the null hypothesis represents a statement of no effect, no difference, or put another way, things haven't changed, right? The alternative hypothesis, H1, this is the statement that you will adopt in a situation in which the evidence or the data is so strong that you reject the null hypothesis. A statistical test is designed to assess the strength of the evidence data against the null hypothesis, right? So there we go. You got to run real quick. Let me just take attendance real quick. I know you was here. I want to get the credit. I want to finish out this topic so that tomorrow we just reviewing and that's it. All right. Give me 1 second. What's this? Real quick before y'all dip. All right. So anyway, right? Step 1 is stating your null or alternative hypothesis, right? Step 2, right, is I want you to tell me what is your test statistic, right? Tell me what is your test statistic. So if you guys look at your formula sheets, look at chapter 9 for the hypothesis testing, right? You're gonna see that there are two, right? There are two test statistics there. Well, there's more than two, but we really focus on the first two, right? You have what's called a z-test, and you have what's called a t-test, right? Looking at chapter 9 in the formula sheet, right? You have a z-test and you have a t-test. There's also a p-test, but don't worry about that, right? Chapter 9, z-test, t-test, right? On your final, you will have a z-test. Okay? On your final, you will have a z-test, right? So I'm not going to go over the t-test. I'm not going to go over the p-test. After the final, if you want to learn about that, come see me in tutor and I got you. We'll talk about it. All right? So step 2 is for you to state that you're having a z-test. Now, what is a z-test? Just copy the formula. Nothing special there, right? X bar minus mu over sigma over the square root of n. Nothing crazy, right? The story that you will be given for the hypothesis test will list all of these variables out for you, so you just plug them in and then that's it, right? Have a good day. Yeah, yeah. All right. Tomorrow. All right. That's step 2, right? State that it's going to be a z-test, right? Okay. Thursday. So real quick, this is the procedure, right? So the requirements, the X distribution is normal with the known standard deviation. Your test will give you a standard deviation that is known for population standard deviation, sigma. Then the X bar has a normal distribution. The sample test statistics X bar has a Z value where Z is equal to X bar minus mu over sigma over the square root of n, where X bar is your mean of a simple random sample, mu is your value stated in the null hypothesis, and n is your sample size, right? I just remembered for the null hypothesis and the alternative hypothesis, I forgot to mention that for HO, you should have mu is equal to something from the story. And then for H1, you will have mu that is either less than, greater than, or not equal to. Right? So I'm just going to write them in parentheses here. It could be less than, greater than, or not equal to some number. Right? The story will tell you what it is. All you're doing is copying it from the story. Whatever question they ask you in the null hypothesis, right? Excuse me, whatever question they ask you in the hypothesis testing question is the alternative hypothesis, the H1. The question is the H1. The null hypothesis is whatever is known, right? So they're going to tell you what it is, right? Let's keep going real quick. I don't know if we're going to get to an example today, so we might have to table the example for tomorrow because of time. But I want to get to step 3. All right. Step 3, after you figure out what is you figure out that it's a z-test, right? I then want you to figure out what is the p-value, right? What is the p-value? So what is a p-value? Let me tell you guys what that is real quick. All right, so once again, this is step 3. And this is your p-value, right? So your p-value, assuming that the null hypothesis is true, is the probability that the test statistic will take on values as extreme or as more extreme than the observed test statistic. Computed from the sample data is called the p-value of a test. The smaller the p-value computed from the sample data, the stronger the evidence against the null hypothesis, right? Long story short, your p-value, I'm going to write it out right here. Your p-value is equal to the probability of your z-test, right? And then I'm just going to put a box right here. In this box, it can either be greater than or it could be less than. I mean, well, this says less than or greater than, right? It's going to go there, right? And how do I know what's going to go in that box, the greater than or the less than? It will be the exact same sign as your alternative hypothesis, right? It will be the exact same sign as the alternative hypothesis. So whatever the alternative hypothesis is, the question that's being asked, that's what your probability inequality sign will be for the p-value. And then, of course, whatever you found for the z-test, that numerical number, that's what's going to go here. And then you just look it up like you do any other probability. Go ahead. This is 3. Step 3, right? And then you just look it up, just like how you do any other probability, right? If you're using if you're using the calculator, it's going to be the norm CDF, blah, blah, blah. If you're not using the calculator, right, you do the Z formula, right? You're going to look that up in a table, and you're going to get the proper probability. Remember that if it's greater than, you're going to subtract it from 1, right? When you're using the table, right? If it's less than, you just copy directly from the table. If you're using the calculator, just copy whatever the answer gives you in the calculator, and that's it, right? That's step 3, all right? Yeah, well, I'm gonna do it tomorrow because we kind of ran out of time today. But let me jump to step 4 real quick. But just so we're clear though, for the p-value, it's the exact same thing as a normal distribution question. Verbatim. It's the same thing as a normal distribution question, right? Let's look at step 4 real quick. So for step 4, right.
Even with the answer.
No, calculator you just copy. That's only for people not using the calculator. Yeah, if you're not using the calculator, then you have to subtract the answers that are greater than from 1. If you are using the calculator, just copy what is in the calculator. Do me a favor, just sign in real quick before you leave. Yeah, I got you. All right. Got you, got you. All right, step 4. Step 4, I want you to conclude, right, your hypothesis test, right? I want you to conclude your hypothesis test. Here's your conclusion right here, right? Procedure. All right, so how to conclude a test using the p-value and level of significance alpha. If the p-value is less than or equal to alpha, we reject the null hypothesis. And you say that the data are statistically significant at the level alpha. If the p-value is greater than alpha, we do not reject the null hypothesis. So what am I looking for in step 4? I'm looking for you to say, I reject the null hypothesis, or I'm looking for you to say, I do not reject the null hypothesis. That's all I want you to say in step 4, right? I want you to make a decision whether you're going to accept the null hypothesis or you're going to reject the null hypothesis. All I want from step 4, right? And then in step 5, I want you to interpret your decision, right? Interpret your decision. So what does that mean, right? Let's say that I reject the null hypothesis, right? My interpretation would then be that there is enough statistical evidence to conclude that the null hypothesis is not true, right? That's if I reject the null hypothesis. Let's say that I fail to reject the null hypothesis, right? I fail to reject the null hypothesis. My interpretation would be that there is not enough statistical evidence to conclude that the null hypothesis is not true. Okay? That's the interpretations right there. All right? I realize I talked a lot. I didn't really give y'all any notes. Here goes your notes right here. All right? These are the basic components of a statistical test, step by step, right? So a statistical test can be thought of as a package of 5 basic ingredients, right? Step 1, state your null hypothesis and your alternative hypothesis and present the level of significance alpha. That will be given to you in the story, the question that's being asked, right? If the evidence, sample data against the null hypothesis is strong enough, we reject the null hypothesis and adopt the alternative hypothesis, H1. The level of significance alpha is the probability of rejecting the null hypothesis when it is in fact true. All right. Step 2 is test statistic and sample distribution, right? So these are mathematical tools used to measure compatibility of a sample data and the null hypothesis, right? On our final, we will have a z-test. All right. So number 2 is done for you already. Partial credit right there. I just hooked y'all up. It's gonna be a z-test. All right. Step 3, you're gonna find the p-value, right? And how do you find the p-value? It's the same thing as the normal distribution, right? It's going to be the probability of z greater than something or the probability of z less than something, right? If you're doing the calculator, norm CDF. If you're doing the table, right, you're going to look it up in the table and that's it. If it's less than, if it's greater than, you're going to do 1 minus. That's it, p-value. Step 4, you're going to give me the conclusion, right? You're going to conclude, right, your test, right? If the p-value is less than or equal to the alpha, we reject the null hypothesis and say the data are significant at the level alpha, or if the p-value is greater than alpha, we do not reject null hypothesis. And step 5, just interpret the test results, right? Give a simple explanation of your conclusion in the context of the application, right? That's it. These are the 5 steps to doing hypothesis test. Tomorrow we'll look at an example where we're going to go through step by step how to do it, right? And then we'll be good. Day after tomorrow, final. All right. All right. Any questions so far though? No? Okay. If you guys want, you guys can go to tutoring and ask for an example for the hypothesis testing and do one in tutoring, right? Tutoring is open right now, closes at 6 o'clock tonight. This is both in person and online. So if you guys want to leave and go home right now and then log in online and do tutoring, that's fine too. All right, whatever you guys want. All right. If you want to go eat and come back, that's fine too. What happened? Oh yeah, yeah. Please come sign in the attendance before you guys leave, please. All right. Is it okay if I stop the recording? Anybody have any questions, stuff? All right. Everybody listening, have a good night. See y'all tomorrow, 10 a.m. CPH 308.